Jai Hind to all. My name is Divya Sharma, Assistant Professor in Electronics and Communication Department in AKGEC. My today's lecture on differential length, area and volume. In the previous videos, as we have already discussed that what are vector quantities, scalar quantities, what are Cartesian coordinates, cylindrical coordinates and spherical coordinates and its transformation. Now today we will discuss differential length. First, it is a vector quantity. Now in rectangular coordinate, as we already discussed in the previous videos, that this is x coordinate, y coordinate, z coordinate, means this is x axis, y axis, z axis. Now we have to find out here differential length for in x axis, y axis, z axis. Now consider some part in x axis that is denoted by dx. Now this is differential length in y axis that is denoted by dy. Now if we are considering some part in z axis, that is differential in z axis, that is denoted by dz. Now write down dl, differential length. How we can write down differential length in rectangular coordinate, or we can say Cartesian coordinate. Now here write down here dx, here y, z are constant. In here you can see x, unit vector of x, now plus dy, this is differential length in y axis, here x and z are constant, this is the unit vector of y, plus dz where x, y are constant and unit vector z. This is also known as, or you can say, differential length or differential displacement. Let us consider a point here in x, y, z coordinate. This is represented as x, and here second point that is represented as b. Let us consider the coordinates of S are x, y, z, and coordinates of point B that is represented as x plus dx, y plus dy, z plus dz. Now find out differential length. How we can find out differential length? Dx unit vector of x plus dy unit vector of y plus dz unit vector of z. We can find out by using these 2 points. Now second is surface area. How we can find out differential surface area? Now this is x axis, this is y axis, this is z axis. Now here you can see this is here unit vector is ax in the direction of x axis. So we can consider while we are writing differential surface area, how we can write down differential surface area? For unit vector x, that is dy dz, means left the part of dx in case of when you have a unit vector of x. Now if we are considering unit vector of y, then you can consider dx into dz. So dx into dz, dx dot dz unit vector of y, and this is the output of ds. If we are considering the case of z axis, so unit vector, in case of unit vector of z, consider that is dx dot dy, means left the part of dz. So this is the way how we can find out differential surface area in x for unit vector x, y, z. Now third one is differential volume. So volume you all know, length, breadth, height. Now in case of Cartesian coordinate, that is represented as differential length in x axis that is represented dx, differential length of y axis that is represented y, differential length in z axis that is represented dz. So differential volume that is equal to dx dot dy dot dz, and here dl differential length, differential surface, that are vector quantities, and dv here means differential volume is a scalar quantity. Now second case is cylindrical coordinate. Here also we have to study differential length, differential surface, differential volume in cylindrical coordinate. So here first we will start with this cylindrical coordinate. Now as you all know, arc is equal to angle into radius, because we have a requirement of this formula in this when we are finding differential length for cylindrical coordinate. Now here you can see x, y, z, these are the axes. Now here already we have discussed what are the how to write down the coordinates of cylindrical and how we can represent the coordinates. So here is, this is rho, this is phi, angle between x-axis and up to where we are considering rho. So this is represents phi and this is represented as rho. If we are considering the part of, first you all know the coordinates of cylindrical. So coordinates of cylindrical are rho, phi, z. So first in this case we are considering the case of rho, and here we are considering the case of phi, and in this case we are considering the coordinate of z, rho, phi, z. So here we have to consider differential length of rho. So we have to consider some part of rho in the increasing direction of rho. So that is represented as d rho. So write down here d, we have to find out differential length. So in the first case, means first case is for rho. So rho you can write down, this is differential rho when we are considering some part of rho. So that is represented as d rho, and this is unit vector of rho. Now second case, considering the case of phi. Now here you can see if your rho is increasing in upward direction, means we are changing some part of rho, so your phi angle is also changing, means because we have to consider phi. So differential phi, d phi, that is represented d phi. If we are considering here d phi, this is the d phi, so you can see rho is also changing, right? So if rho is also changing, you can write down here rho d phi. While considering this formula, you can write down rho d phi. So here when you are considering the unit vector of phi, so here consider the part of rho d phi. So write down here rho d phi plus, now here this is the third case for z axis. Now consider some part of z, okay. So here you can see this is some part of z. So write down here nothing is changing except the z axis. So consider the sum that is represented as dz, differential part, differential length of z axis. So you can write down here dz az, this is unit vector of z. So this is the formula for differential length in case of cylindrical coordinates. So here you can write down differential displacement or differential length. So that is represented d rho, unit vector of rho, plus rho d phi, unit vector of phi, plus dz, unit vector of z. Already we have discussed in the previous slides how we can derive this dl. Now third is differential surface area. Now you can see this is x-axis, this is y-axis, this is z-axis. Now first we have to consider this rho part. This is the direction of rho, as we have already discussed how we can draw the diagram for cylindrical coordinate system. So rho, its direction is in this direction. Now you can here you have to write down differential surface area for unit vector rho. So while we are considering the unit vector of rho, write down here rho d phi dz. Now already we have discussed in the previous slide. So you can see here for unit vector rho, this is d rho. For unit vector phi, rho d phi. Unit vector z, dz. If we are considering the case of unit vector az, so we have to consider d rho in dot rho d phi. If we are considering the case of rho, then we have to write down rho d phi dz. If we are considering the case of phi, means unit vector phi, then we have to write down d rho and dz. So you can see this slide. When we are finding differential surface area, so write down, if we are considering the case of unit vector of rho, then write down rho d phi dz. If we are considering the case of phi, so write down here d rho dz. While we are finding ds. Now consider the case of unit vector of z, write down here rho d phi. So this is the way how we can find out differential surface area in cylindrical coordinate system. Now third is differential volume. So as you all know, differential volume, dV, that is represented as dV, that is equal to rho d phi dz. Okay. Now, in the case of spherical coordinate system, as we all know, these are the coordinates r, theta, phi. So, in the first diagram, we have to take the differential r. Now, in the second case, differential theta, and the third case, differential phi. Here we can see here, this is the radius, as already we have discussed in the previous videos that how we can draw the spherical coordinate system. Now here this is r, this is theta. Theta is drawn in between z axis to r. So that is represented as theta. Now here in the first case we have to consider d, differential radius. So we have to take some part of radius in the increasing direction of r. So that is represented as dr. So write down here dr, unit vector of r. Now second case, when we are considering d theta. So you can see here, this is your radius. Theta is in angle in between z axis to r. So if we are varying this d theta from here to here, so we can see here this r is also in this direction, or we can find out the previous formula. By using that previous formula, we can find out that is equal to r d theta. So in the direction of a theta, unit vector theta, write down here r d theta. Now third case, while we are considering the phi case, so d phi. So as you all know, your rho is in this direction and phi from angle in between z x axis to this rho. And if we are considering the case of differential d phi, so you can write down it like this, rho d phi, as we have already discussed in the cylindrical coordinate also how we can find out differential phi. So write down here rho d phi. So consider here rho d phi, unit vector of phi. Now here if you want to write down these dl in the coordinates of spherical coordinates, so here write down rho is equal to r sine theta. So dl in case of spherical coordinates, write down here dr, unit vector of r, plus r d theta, unit vector theta, plus r sine theta d phi, unit vector of phi. So this is the differential length for spherical coordinate. Already we have discussed how we can find out dl. So dl, this is the formula for dl, or we can say differential displacement. Now second point is we have to find out differential surface area. How we can find out differential surface area? First we have to consider the unit vector ar. While we are considering unit vector ar, so we can find out it like this, AR. If we are considering AR unit vector, so we have to multiply, while we are finding DS, so we have to multiply R d theta into R sin theta. If we are considering the case of theta, unit vector theta, so we can multiply if we are finding DS, that is equal to dr into R sin theta d phi. If we are considering case of unit vector of phi, then we can note down it like this, ds is equal to dr into r d theta. So this is the way how we can find out ds, or we can consider it like this, this is unit vector of r, here you can write down r sin theta in d phi r d theta. So write down ds is equal to r square sin theta d phi, this here unit vector r. Now if we are considering the case of unit vector theta, so ds is equal to r sin theta dr d phi. Now third case, so here consider the direction of phi is in phi direction is in the angle, where we can write down angle means direction of phi. So here consider the unit vector phi, then you can write down ds is equal to r dr d theta, unit vector of phi. So this is the case for differential surface area. Now third one, differential volume. So differential volume, so write down it like this, that is represent dV. Now write down it like this, dV is equal to what? dV is equal to dr r d theta r sin theta d phi. So write down it, r square sin theta dr d theta and d phi. So this is differential volume. Let us consider an example. Here we have to find out, this is in x-axis, y-axis, z-axis, and coordinates are given for A point, B point, C point, D point, and this is origin, this is F point. Now this is your figure for this question, and we have to find out length BC, length CD, surface area ABCD, and the fourth case is surface area ABO, AOFD surface area, and the last one is volume ABCDFO. Now first write down its coordinates. As already we have given this coordinates of A 5 0 0. So these are in form of Cartesian, right? And this is the case of cylindrical. So write down its coordinates in cylindrical form. So how we can write down in cylindrical form? As you all know, we have to write down rho phi z. So rho, this is your rho is equal to phi, already given in the question, that A is equal to 5, 0, 0. Now write down its coordinate in cylindrical form. So this is rho already we have given, that is phi is here, this here phi angle is equal to 0 and z is also equal to 0. Now for B point, means B point write down in cylindrical form. So here write down rho phi z. So as you all know, this is also rho phi. So write down here phi 5. Now rho phi is angle between the angle between x-axis and y-axis. Now as you all know, x-axis, y-axis, z-axis are perpendicular to each other. Now you can find out easily, you can find out phi is equal to 90 degree. Angle between x-axis and y-axis, as you all know, write down here phi is equal to 90 degree. So write down it like this, pi by 2 comma z. Here z is 0. Now find out the coordinates for C point. Here you have given 0, 5, 10. But we have to find out, write down coordinates in cylindrical form. So rho is equal to, this is your rho phi, write down here 5. Now angle in between, angle phi, that is equal to pi by 2. Now z is equal to 10. Why it is 10? You can see here this point, z is equal to 0 and here z is equal to 10. So z is equal to 10. Now write down the coordinates of D point. As you all know, rho is equal to phi. Now phi angle is here 0. So write down here 0. Now height, z axis is here 10. So write down here phi 0, 10. So these are the coordinates for D point. Now you can write down the coordinates for F also. Rho is equal to here, at this point rho is equal to 0, phi is equal to 0. But z is equal to 10 because we are considering the case of z. Now here z is 0, z is 10. So write down here 10. So this is the way how we can write down the coordinates in cylindrical form. Now first is find out BC. So here you can see BC. Now coordinates, you can check coordinates of B and C point. Here rho is 5, here rho is 5. Phi is also pi by 2 same. And z is changing, right? So if z is changing, write down here, find out dl, means dz. If z is changing, then write down your bc. You can find out it like this, integration 0 to 10, because z is 0 to 10. So write down here z is 0 to 10 dz. Now we can find out integration of this, then that is equal to 10. Now second point, find out the length CD. So as you all know, you can check CD. So here rho is same 5 and phi is changing from 0 to pi by 2 and z is same. So which one is changing? Rho is changing. So your integration is in form of phi, because phi is changing from 0 to pi by 2. So write down integration 0 to pi by 2 rho d phi, and you can find out the integration for the same. That is equal to 2.5 pi. Now the third case, we have to find out differential surface area for ABCD. Now ABCD, this is the surface area. Now you can check here. Now you can write down it in form of z and phi. as you all know, you can write down its direction. If you are considering the direction of phi, then here in this direction, that is in negative form, here in outward direction, that is in positive form, right? Here you can see rho is positive here, and inside that is negative. So write down in the form of phi and z. While you are considering the case of surface area of A, B, C, D. So you can see here in A, B, C, D, rho is same. So if rho is same, write down here rho d phi, means if rho is same, so write down in form of phi and z. So rho d phi dz, and your limits are for z. Z is 0 to 10 and phi is 0 to pi by 2. So like this you can find out the surface area for ABCD. And if you are considering the case of in D part ABO, so ABO, you are considering this surface area. Now while you are considering this surface area, your Z is 0. Z is same in both cases. So if Z is same in both cases, so integration in form of d phi and d rho. So write down here rho d phi d rho, and you all know your rho is changing from 0 to phi and phi is changing from 0 to pi by 2. So like this you can find out its area, that is equal to 6.25 pi. Now for E part, find out the surface area of AOFD. Now AOFD. Now here you can see your phi is same and other values are changing. So if phi is same, so write down your integration in form of d rho and dz. And rho, you all know, you can see, check from this figure, rho is changing from 0 to 5. Now write down here rho is 0 to 5 and z is equal to, means z is from 0 to 10 and your phi is 0 here. So write down your integrations, you can find out surface area in this form, that is equal to 50. Now in the last part we have to find out the volume for A, B, C, D, F, O. So write down here the formula rho d phi dz d rho, and you all know you can write down the limits. Rho is equal to 0 to 5, pi is equal to 0 to pi by 2, z is equal to 0 to 10. So like this we can find out the volume, that is equal to 62.5 pi. Now line integral. Line integral is, this is the formula for line integral, as we have a unit vector, as we have a vector that is represented as A dot dl is integral of the tangential component of vector A along L. So this is the formula for line integral. Now we have two cases. Your line is, let it be your line is open or closed. If this is your field that is represented as A. Now we are considering a line and this is the path of the line A to B, means your lower limit, your start point is A and your end point is B for open line, and you are considering some part of this path that is represented as DL, and angle, considering the angle which is drawn in between this line to this field, that is represented as theta. So your formula is for open line, lower limit A, means start point, end point. Now here A magnitude cos theta dl. So this is the line integral of A around L for open line. Now if you are considering the case of closed line, closed line means what? Your start point is this, your end point is, if you are considering this path, and again you are reaching up to this point A. So you can write down its integration like this. You have a closed line. Now A dot dl. This is the circulation of A along L. Now surface integral. Surface integral is represented as surface integral or flux of A, though as is, this is represented as flux, that is equal to A dot ds. Integration A dot ds. Now this is the surface, this is the surface area. Here we can see this is unit vector, this is your surface area. Now you are considering angle in between unit vector and surface. Now this is your field. Now write down it as we have done in the line integral. We can write down for surface integral, that is A dot ds, and in the line integral that is represented A dot dl. So flux is equal to integration A dot ds. Now surface integral for closed surface. Now closed surface, you can change the part, integration part, you can draw it like this. This is your closed surface. Now A dot ds. So same, you can represent flux in case of closed surface, only the difference of integration sign. So a closed part defines an open surface. Let it be, you have a path like this, this is your open surface, and you have a surface in form of closed volume, that is your closed surface. Now volume integral is equal to rho v dv. So this is your volume integral of scalar rho over the volume v. Let us take an example. Calculate the value of ADL where C is the curve and curve is y is equal to 2x square. Joining the points, this is your first point, this is your second point, 0, 0 and 1, 2, where A, your field, the A is equal to 3xy unit vector x minus y square unit vector y. So this is your A. So step 1, first write down A is equal to integration 3xy dx minus y square dy. Now you all know how to draw its diagram. This is your initial point 0, 0, your final point 1, 2, and you have a curve y is equal to 2x square. Now you have you have to find out this. Now you can see y is equal to what? Y is equal to 2x square. So put the value of y in this integration dx. So y is equal to 2x square. Now we can find out its integration. How we can find out? As we all know, it's your initial points are 0, 0, your final points are 1, 2, and this is in 2D. As you all know, you can see this is in 2D, means dx you can find out for dx and dy, and that is equal to minus 7 by 6. Let us consider another example that is in 3D. Let us consider that is A vector is equal to 2y plus 3 unit vector x plus xz unit vector y plus yz minus x unit vector z. Now you can see C is the line joining. These are your points in 3D. So x1, this is x1, y1, z1, 0, 1, 1, 2, 1, 1. So that is x2, y2, z2. Now you can write down in this form A dot dl. So A dot dl, this is your A. Now write down here dx. This is your y, means here xz, and dy, and this is yz minus x. So write down here dz. So this is your first step, how we can write down A dot dl. Now you have given points x1, y1, z1, x2, y2, z2. Write down it like this: x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 equal to z minus z1 upon z2 minus z1 is equal to t. So you can see here denominator is equal to 0. If denominator is equal to 0, write down y is equal to 1. If y is equal to 1, then dy is equal to 0. Here you can see 1 minus 1 is equal to 0. It means z is equal to 1. If z is equal to 1, so dz is equal to 0. Here you can see x is equal to 2t. So x is equal to 2t, dx is equal to 2 dt. So put all these values here and you can find out the value. So here your limits for x, as it is given, x is varies from 0 to 2. So write down its limit 0 to 2, 5 dx, you can find out the value that is equal to 10, or you can change it in form of t. And if you want to change it in form of t, x is equal to 0 to 2, 2t is equal to 0 to 2, t is equal to 0 to 1. So you can find out it like this in the t form. Now del operator. So del operator is written as this in this form. This is the vector differential operator. In Cartesian coordinate, you can write down it like this: del is equal to del upon del x unit vector of x plus del upon del y unit vector of y plus del upon del z unit vector of z. Now gradient of a scalar vector v, that is represented as del v. Now if you want to write down divergence of vector A, so you can write down it like this, del dot A. Now curl of vector A is represented as del cross A. Laplacian of scalar V, that is represented del square V. Now del operator you can write down in Cartesian form, cylindrical form, spherical form. Now this is the way how we can write down del operator in these coordinates. Now in Cartesian coordinates, del is equal to del upon del x unit vector of x, del upon del y unit vector of y, del upon del z unit vector of z. In cylindrical coordinate, del is equal to a rho del upon del rho plus a, this is unit vector of phi, 1 upon rho del upon del phi plus unit vector of z del upon del z. Now spherical coordinate, del is equal to unit vector of r del upon del r, unit vector of theta 1 upon r del upon del theta plus a phi, unit vector of phi 1 upon r sin theta del upon del phi. So this is the way how we can represent del operator in these Cartesian, cylindrical and spherical coordinate. Now gradient of a scalar. Now gradient of scalar is a vector that represents both the magnitude and direction of the maximum space rate of increase of V. Now this is represented as gradient V is equal to del V is equal to del V upon del x unit vector of x plus del V upon del y unit vector of y plus del V upon del z unit vector of z. Now we can write down gradient of a scalar in Cartesian form, cylindrical form, spherical form. So first we are considering the case of Cartesian. Del V is equal to del V upon del x unit vector of x plus del V upon del y unit vector of y plus del V upon del z unit vector of z. This is the case for Cartesian. Now consider the case for cylindrical coordinate. Now del V is equal to del V upon del rho unit vector of rho plus 1 upon rho del V upon del phi unit vector of phi plus del V upon del z unit vector of z. Now in the case of spherical coordinate, how we can write down gradient of a scalar? Del V is equal to del V upon del r unit vector of r plus 1 upon r del V upon del theta unit vector of theta plus 1 upon r sin theta del V upon del phi unit vector of phi. Let us consider an example. Find the gradient of the following scalar fields. First part is V is equal to e ki power minus z sin 2x cos hyperbolic y. B part is equal to u is equal to rho square z cos 2 phi, and C is equal to w is equal to, C part is w is equal to 10 r sin square theta cos phi. So these three parts we have to do. Now find out gradient for all these three. Now gradient, as you all know the formula, del V is equal to gradient V is equal to del V upon del x unit vector of x plus del V upon del y unit vector of y plus del V upon del z unit vector of z. Now put the values here. In this case you can find out the gradient V. So as you all know the formula for gradient, and so put all these values, this one here, and differentiate it in respect of x, then differentiate in respect of y, then differentiate in respect of z. Then we can find out this is the in respect of x, then this is in respect of y, this is in respect of z. Now second case, again we have to do it like this. Similarly we can find out gradient of scalar fields for all these three parts. Thank you. Now next topic we will cover in the next video lecture.